All right, today we're going to talk about natural log function and how to take the derivative of that. Before we learn about the derivative, I want you to go ahead and try problems 1, 2, and 3 on your own, and I'm going to give you about 45 seconds to do that. All right, let's take a look, and I'm guessing you probably had a little problem with number 3, but that's okay. That kind of leads us into what we're talking about today. So for number 1 here, antiderivative, all we're doing is adding 1 to the exponent and multiplying by the reciprocal of the new exponent, and don't forget our plus c. Same thing for number 2, only here we may want to rewrite this as x to the negative third dx. Now add 1 to the exponent, so we get negative 2, multiplied by the reciprocal of that exponent. Don't forget our plus c. Now if we try the same thing for number 3, think of it as x to the negative 1 dx. If we add 1 to that exponent, we get x to the 0, and then we multiply by the reciprocal of that, we get 1 over 0. Well, we can't have 1 over 0. This is not going to work. We can't do that and use that same rule when it's 1 over x. All right, so let's take a look at the definition of the natural log function. Natural log of x actually equals the definite integral from 1 to x of 1 over t dt, as long as x is greater than 0. So let's think about what this means. Natural log of x is equal to the definite integral from 1 to x of 1 over t dt. Let's take a look at a graph. This is the graph of 1 over t, and if we're taking the definite integral from 1 to x, that means we're finding the area under the curve from 1 to whatever x value we choose, and that's going to give us the natural log of x. So for example, if we had natural log of 2, that'd be the definite integral from 1 to 2 of 1 over t dt. So we'd be looking at the area under the curve from 1 to 2. So this little region would define natural log of 2. And natural log of 20, we'd have to do the definite integral from 1 to 20 of 1 over t dt. So the area under the curve from 1 to 20 way out there. So the next part here asks us to compare the following values. So you can see, like we were just talking about up here, natural log of 2, we want to see what that's equal to, and the definite integral from 1 to 2 of 1 over t dt. So that's just basically putting 2 in for x and showing you, if you look here, if we take natural log of 2, we get 0.693 and so on. Definite integral of 1 over x dx from 1 to 2, 0.693. So both of those come out to the same thing, right? And we will find that the same thing happens with these. For number 5, we take the definite integral of 1 over x dx from 1 to 1/3, we get negative 1.099 if we round it. Same thing for natural log of 1/3. Oh, sorry, I got that. It should be 0.099. And for the last one here, number 6, natural log of e, that's one you should hopefully know. That is just 1. Right, natural log of e to what power gives us e? It's 1. And here, if we go from 1 to e, the definite integral from 1 to e of 1 over t dt, we also end up with 1.